Alright, so this is the chapter 4 review. If you guys have any questions or anything, by the way, while I'm doing it, just say so. Otherwise, I'll just go through it because I'm going to record it and put it on YouTube. So, okay. Alright, so the first one, we're given two different inequalities, and then we're given the OR symbol. Since it's the OR symbol, we know it's going to be a union. So we're going to include both of them in our solution set. So the easiest way to find out what graph goes to which one is to solve for the variable. So the first one here, I have 3x plus 2 is less than negative 1. So to solve for x, I'm going to subtract 2 on both sides. So I'll get 3x is less than negative 3. Divide by 3 on both sides, we get x is less than negative 1. Okay? So it's specifically a less than symbol. So it's not going to be the bottom two. So this bracket here is just like a closed dot. The parentheses is just like an open dot. So I know it's going to be one of these two. And I see they both start at negative 1. But I want everything that's less than negative 1. So everything in A is going to be less than negative 1, right? Because negative 10 is going to be less than negative 1. Negative 5 is less than negative 1, and so on. It's going to be answer A for number 1. The second one, we're going to do the same thing to solve for x. So we can add 8 on both sides. So we'll get 2x is greater than or equal to negative 10. And we divide by 2 on both sides. We get x is greater than or equal to negative 5. Since it's greater than or equal to, we know it's going to be one of the two solid dots up top. We know it's not going to be D or C. And then we're looking for things that are greater than negative 5. So if I look on the graph, well, I see 0 here, and 0 is definitely greater than negative 5. So it's going to be letter B. Now that I see these are my two graphs, and I know that it's an OR, I can just combine them. And if I combine them, it looks like, let's see, well, it goes from negative 1 down, right? So if I look at the graph, it's probably somewhere around here. It goes that way. And then the other one's negative 5 and goes up, right? So that'll cover the whole graph. So it should be letter A. So my solution set in words, in interval notation, it goes from negative infinity to positive infinity. Okay. Number 2, this one says find the solution set of 7 multiplied by the absolute value of 2x minus 5 equals 49. So the first thing we want to do is simplify it down to the absolute value. So I'm going to divide by 7 on both sides. So we get the absolute value. The absolute value of 2x minus 5 is equal to 7. And we know the absolute value is just the positive distance, or just the distance from 0, right? And it's always going to be positive. So we could have this, so we could have 2x minus 5 equals 7. But we could also have 2x minus 5 equals negative 7. Okay. And then from here, you just need to solve for x. So we add 5 on both of them. So we get 2x equals 12 and 2x equals negative 2. Divide by 2 on both sides. We get x equals 6 here and x equals negative 1 here. So my solution set is going to be these two numbers. So negative 1 and 6. And that'll be letter A. All right, on the next page, we have a similar problem. So I'm going to do the same steps as I did on the last one. I'm going to divide by 2 on both sides. So we get y plus 11 equals 5, and y plus 11 equals negative 5. Same thing, solve for y here. Subtract 11 on both sides, so we get y equals negative 6, and y equals negative 17. So my solutions are negative 6 and negative 17. Okay. On number 4, this time it's going to be a little bit more complicated because we're dealing with fractions here and we have an inequality symbol. So I think the first thing that I want to do is I want to eliminate all the fractions. So the way I can do that is multiplying everything by 1, but doing that in a special way. So I think what I'm going to do is I'm going to multiply everything by 24 over 24. Right? Because 24 over 24 is still 1. But what that's going to do is it's going to cancel this 24. I know 12 is a multiple of 24, so that'll cancel. And I know 8's a multiple of 24, so that'll cancel as well. So if I do that, 24 divided by 8 is 3, so I have to multiply the top by 3. So we have 3 multiplied by x minus 12 is greater than or equal to, I know there's 2 12s and a 24, so I have to multiply x minus 6 by 2. And then 24 and 24 will cancel, so we just have plus 7. Now we need to get all the x's on one side and all the constants on the other. So the first thing I'll do is distribute both of these. So if we do that, we get 3x minus 36 is greater than or equal to 2x minus 12 plus 7. So I'll subtract 2x on both sides and I'll add 36 on both sides. If I do that, we just get x is greater than or equal to negative 5 plus 36, we get 31. So we're looking for x is greater than 31, right? So if I want to do that in interval notation, well, my lowest number is 31, and that's in a bracket, and my highest number goes up to infinity. So looking at the graph, it should be letter B, because it starts at 31, and it's a solid bracket all the way up to infinity. Okay. Number 5, the inequality t minus 56 is less than or equal to 6, describes the range of monthly average temperatures in Fahrenheit for a large city. So it says solve the inequality and interpret the solution. So again, whenever I have an absolute value, I know it's going to be between 6 and negative 6. So my interval looks like negative 6 is less than or equal to t minus 56, which is less than or equal to 6. Then to solve for t, we add 56 on all 3 sides. And we get 50 down here is less than or equal to t, which is less than or equal to 62. So interpreting that, that means our low is a 50 and our high is 62. So that would be letter A. Okay. On the next page, we're solving a linear equality again. So we want all the x's on one side and everything else on the other side. So I think I'm going to subtract 3x on both sides. And then we're going to add 12 on both sides. So we get 7x is less than or equal to, and that'll be what, negative 2. Divide by 7 on both sides, we get x is less than or equal to negative 2 over 7. Okay, so if I look at my charts, I know it's not going to be the first one because I definitely have not the whole number line, so I know it's not A. I know there is a solution, so it's not E. Let's see, I'm looking for values less than negative 2 over 7. So it looks like this is at less than negative 2 over 7, but it's a parentheses, right? So that's the same thing as an open dot. So that's not it. And that also means D is not it because it's a parentheses. So I have one of these two choices. And I know that it's less than negative 2 over 7. So it's going to be F because those are all my values less than negative 2 over 7. So letter F. All right. On the next one, we have a compound inequality. So this one's AND, which specifically means that it's the intersection of these two. So we're going to do the same like we've been doing. We're going to solve for x for both of them. So on the first one, I think what I'm going to do is I'm going to divide both sides by 2 first. So I have 1 minus x is less than negative 7 over 2. Then I can subtract 1 on both sides. So we'll have negative x is less than negative 9 over 2. And then I can multiply or divide by a negative 1. Since I'm multiplying or dividing by a negative number, I have to flip the inequality. So x is greater than 9 over 2. So that's my first one. If I look at that on my charts, let's see. Well, I know it's going to be a parentheses or an open dot, so it's not going to be B or C. And I'm looking at everything greater than 9 over 2. So in this case, it would be letter A. Okay. The next one, for this one, I'm going to multiply by 4 on both sides. So I get x minus 6 is less than or equal to negative 8. Then I can add 6. Add 6 on both sides. So we get x is less than or equal to negative 2. So if I look for this, I know it's not going to be the first two because they're the open dots. C and D, it looks like D is going to be your choice, right? Because it's greater than negative 2. Okay. Now what I want to do here is kind of combine these two graphs. So if I combine these two, because I want the and. Actually, I'm sorry. It should be the other one, right? Because we want everything less than negative 2. So it's going to look like this one. Okay. So since this is the intersection, we want everything that these two graphs share in common. So if we look, it looks like everything on C stops right here, while everything on A stops right here, right? So they don't have anything in common. And since they don't have anything in common, that means our answer should be A for this third one, right? So they share nothing in common. And since they share nothing in common, that means they're going to be the empty set. Okay. So for number 8, we have the absolute value on both sides. And basically what that means is that we just have one side and we're taking the positive and the negative of the other side. So we can say 2x or 2/3 x minus 1 is equal to 1/3 x plus 3. And it's also 2/3 x minus 1 is equal to a negative 1/3 x plus 3. So to solve this, I think I'm going to multiply by 3 on both sides. So we get 2x minus 3. I'll go up. 2x minus 3 is equal to x plus 9. We'll have the same thing over here, but the right side's negative. So we'll have 2x minus 3 is equal to a negative x minus 9. Then we can solve for x now. So I'll subtract x on both sides here, and then we'll add 3 on both sides, so we'll get x equals 12 for this one, for the left one. And then on the other side, we can add x on both sides, so we'll get 3x is equal to, we'll add 3 on both sides, we get negative 6. So we get 3x equals negative 6, meaning that x is going to be a negative 2. So my solution set here are just the integer solutions that I got, negative 2 and 12. All right. On the next page, this one says find the solution set for this equation. Since it's an equation, we're only going to have one solution. So I'll subtract 7 on both sides first. So we'll get the absolute value of x plus 1 is equal to negative 3. And that means that I'm going to take the positive and the negative since I'm taking the absolute value. So I have x plus 1 is equal to negative 3, and x plus 1 is equal to positive 3. On both of them, I'll subtract 1 on both sides. We get x is a negative 4, and x is 2. So my solution set's negative 4 and 2. Number 10 says find the intersection, so what they have in common. It looks like we have 3 elements over here, and this is just the null set, or there's just no solution in the set, empty set. So the intersection is also just going to be the empty set. Okay. Number 11 says solve this inequality and graph the solutions. So I don't really like dealing with fractions, but the first thing I think I'll do is add 10 on all the sides. So add 10 here, add 10 here, add 10 here. If I do that, we get a positive 2 over here. We get 2 is less than or equal to 2/3 x, which is less than 8. Then what we'll have to do is we'll have to multiply by 3 all the way through. So we get 6 is less than or equal to 2x, which is less than 24. And then finally divide everything by 2. So we get 3 is less than or equal to x, which is less than 12. So we see that x is bounded by two finite numbers, which means that we're going to have a graph that looks something like A or D, right? Because we're not going to go out to infinity on either side. So if I look at A, I see it's bounded at 3 and bounded at 12, what we want. But this one is a closed dot, right? And this one's an open dot up here, so it can't be A. So our last choice is D. Okay. So this is the union. Since it's the union, it's just all the elements in either one. So we start at 0, then we have 2, 3, 4, 5, 6, 7, 8, and 9. So this one is specifically an OR, so it's in A or B. The last page here, this one's an OR, so we know it's going to be the union of these two. So all we're doing here is just solving for x. So I'll divide 2 on both sides. We get x is greater than 4. On this side, we divide by 3 on both sides. We get x is less than negative 5. So which one is x greater than 4? Well, that would be this one right here. And x is less than negative 5 would be this one right here. And notice, if we combine these two graphs, if we look at, oops, it actually should be the left of it, right? So that should be this one right here. It should be D. So if we combine those two, we should see something like this one, right? Where we have strictly less than, right? Those are open dots. We have one that's greater than 4 and one that's less than negative 5. So my interval notation here should be, we go down to negative infinity. We go all the way up to negative 5. And we have to make a union with 4 all the way up to infinity.